All right, welcome back. We're going to crank through a ton of problems in square roots, and we have so many lessons ahead on all of this, it's not even funny. So we're going to just get started. You're going to be very, very comfortable with square roots by the end of it here. So let's just start cranking through it. What if I gave you 36 and I said, hey, find the principal root or the positive square root of this guy? Now you already know the answer, but I want you to use the factor tree method. So what you do is you try to figure out what times what gives you 36. Now I'm going to do this problem a few different ways actually, to show you that it doesn't really matter what you pick. The first thing I think of is 6 times 6. That's just the first thing I think of from my multiplication table. So I'm looking for pairs of numbers, so I can really stop here. Now it is true that 6 can be written as 2 times 3, but I don't really need to go down any farther in the tree because I've already found a pair. So I can just circle this, and when I pull it out, I only pull one of them out, so I can say that the answer is just 6. And that's the answer, because 6 times 6 is 36. That's the correct answer. Now let me do this problem a few different ways to show you that it doesn't really matter exactly what your factor tree looks like. You're going to get the same answer. Let's go back to take the square root of 36. Let's pretend that I didn't realize that 6 times 6 was, let's just say that wasn't the first thing I thought of. Let's say 12 times 3 was the first thing I thought of. So I'm looking for a pair. I don't see any pairs here. I see a 12 and a 3, so I can't do anything. I can't pull anything out of the square root unless it's a pair. But 3, you see, I can write it as 3 times 1, but that doesn't really help me any because it's already a prime number. I need to continue going down the tree as far as I can until I hit prime numbers where I really can't do it very much anymore. I mean, I can write it as 3 times 1, but I haven't changed anything. I've got the same numbers. But then I realized that 12 can be written as a lot of things. I can do 3 times 4, or I can do 2 times 6. And really, it doesn't matter what you pick. So let's just go with 2 times 6. Let's say that's the first thing that I think of. So here I'll have 2 times 6. So again, I'm looking for pairs of numbers. I have a 2, a 6, and a 3. I don't have any pairs anywhere in here, so I can't really pull anything out. But then I realize, well, this is prime. I can't really, 2 can just be written as 1 times 2. I can't really go and make the tree any deeper. But 6, I can continue writing this and saying that 6 is 2 times 3. So you see what happened is I broke 36 into a big tree. And at the bottom of the tree, I have a 3, I have a 3, I have a 2, and I have a 2. And now I have some pairs. So you want to keep going until you have pairs and until you can't write the tree anymore. So here I have a pair, the 3s, and here I have a pair, which are the 2s. And I told you that for each pair, you can only pull one of them out. So when it comes to the 2s here, I can only pull one of them out. But everything's multiplied together in this tree, so it's multiplied by the 3s, but I can only pull one of those out because it's a square root. So I have 2 times 3 because they're at the bottom of the tree. 2 times 3 gives me 6. That's the answer, which is exactly the same as the first answer. You see, I just happened to think 6 times 6 immediately, so I had a pair, I pulled it out, boom, I'm done. There's nothing else to do. Here I didn't notice that. Let me do this problem one more time, just to show you that you have a lot of variety here. Let's say we had 36. Let's say I did exactly the same thing, 12 times 3 initially, and then I want to break up the 12. But I don't think 2 times 3. Let's say I think 4 times 3 is equal to 12. Now I have a pair, that's true, I have a pair, but I want to keep writing this tree as far down as I can go, all the way to the bottom, so I can write 4 as 2 times 2, basically until you don't have anything further that you can go. Like I can only write 2 as 1 times 2. That's not very interesting. It's